and you probably know why. So let me just go over quickly the San Diego C++ meetup slide. This is recorded and would be uploaded to our YouTube channel later today or tomorrow morning. This is sponsored by Qualcomm WRD software, which I'm part of. Thank you, Qualcomm, for sponsoring that. Qualcomm is paying our meetup fee. Special thank you for my VP, Charles Bergen, that is sponsoring that. We have a Dropbox link where we upload material, and it's mostly the slides. We have a Slack channel. We have a Discord channel. The YouTube channel is DCPP Meetup, where I'm uploading the sessions. I have a Twitter handle as DCPP Meetup, which you can follow. My Twitter handle is Kobe_CA, which I'm very active, tweeting about software engineering, like C++, Rust, Python, and so on and so forth. Just want to mention Martin's blog, which I highly recommend everyone to look at. Lots of material. Without further ado, let's talk about the agenda. Well, we have Amir Kirsh with us, presenting 6 ways for implementing Max, a walkthrough API design, dangling references, and C++ 20 constraints. You already have that abstract in the meetup, so I'll just go and just introduce Amir. Amir Kirsh is a C++ lecturer in the Academic College of Tel-Aviv-Yaffo, which I basically graduated there, and dev advocate at Incredibuild, which we are using here in our teams. He's also a co-organizer of the Core C++ conference and a member of the Israeli ISO C++. Thank you, Amir, for coming over. I'm very happy to have you. Just before you start, I have this thing that I wanted to present. So Amir he was my C++ teacher in '98, and I still have his handouts. I don't know if, let me see if people can, it's just gonna unblur it. Let's see.
Which is useful for anybody who reads Hebrew.
It's, yeah, so Exhibit A, B, C, and D. Are you familiar with this?
Yes, I do. And today, there were years where it was, as a single booklet. And today I just released it as a PDF file. So if you want a new version in Hebrew as PDF, just let me know.
I would be very happy to have it. I must say that you brought me into this domain. I kind of fell in love in this language. Thanks for you. Thanks to you. It's you are the first one introducing this to me, and I still remember the classes from '98 very, very vividly. So thank you. That's it. That was the introduction. Thank you so much. I'm gonna stop presenting, and it's all yours.
Thank you very much, Kobe. And yeah, it is exciting to be here and to see my endnotes from it is 1998. I was quite young there. I was still a PhD student. Started to teach C++ at the Academic College of Tel-Aviv-Yaffo, and I'm still teaching C++. So many years passed by, and C++, it's not the exact same language, but I love it the same as I loved it way before, with many new things to talk about, to teach. And this is, by the way, another talk that I'm giving occasionally about how to teach C++, which is a language that is true for any language, but C++ is quite evolving, and you have to change the materials. And at the end, you have to squeeze into the same semester new materials. And this is a challenge, but I would not talk about that today. So let me share my slides, and let me show you what I would talk about today. I think that this is, yeah. So you would see my slides now.
Mm-hmm, yeah.
So
Now,
6
yes,
ways
yes.
for implementing max. I would ask you not to count that we reach 6, because maybe we would reach 5 or 7. You know, it's the liberty of the speaker just to drop a number. But we would walk through API design, dangling reference, and a bit of C++20 constraints. So I was introduced already. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and also at Tel-Aviv-University. I'm the dev advocate at Incredibuild, a member of the Israeli ISO C++ national body. I'm not sure that you know, but the ISO C++ has national bodies in order to make sure that any decision that is taken would not, hurt or do something that does not work, that would not work with industry. And for that, there is a need to make sure that it is checked, it is reviewed by industries around the world. This is a requirement by the ISO. So we have, there are many ISO national bodies in many countries, and we have also one in Israel that was established, I think, about 2 or 3 years ago. And I'm part of this discussion group, and also a co-organizer of the core CPP conference and meetup group. I'm also a dev advocate at Incredibuild, so just the marketing plug. If you're suffering from slow builds, and I know that in Qualcomm you're using Incredibuild, maybe there are other groups in Qualcomm that do not, then maybe you should know, or others which are not from Qualcomm. If you're suffering from slow builds, we can assist you. And it is not just waste of time, it affects your dev cycles and productivity, so feel free to contact me about that. I would also add that we also accelerate Yocto builds. So if you are in embedded Linux, we had 2 talks recently in the Yocto Project Summit. These are the links, and you would have the presentation later, so you would be able to click the links, and a link to Incredibuild and Yocto on Incredibuild's site. So this is about Incredibuild, what I wanted to share with you on that. And let's just go quickly to the initial challenge. So we want to have something that would calculate max, that would find the maximum value out of some, set of values of any type. Let's assume that we have strings, and we want to find the maximum of these 3 strings. Oh, it is all allow here for some reason. I think that while preparing slide, I didn't change them, but yeah, you can ask for the maximum of all 3 allows. It should work as well. We have here 2 calls, one with lvalues and the other one with rvalues. And by the way, it is rvalues of a string. The additional s at the end, if we had using namespace stud string literals, this would make that a string. And at the end, what we want to achieve is to support all kinds of calls with different values, with different combinations, and to be efficient. So, and it is important for me just to mention, I didn't say that before, feel free to participate. I mean, it would be a quite interactive session. So now I'm just talking, and you can still, stop and ask or comment. And in a few slides, we would just go to the code, and you would just assist me by telling me what we should try. So we have here 2 calls to my max. It might be that we call the same function. It might be that we have overloading. And the question is, what should we consider? Now, the idea with C++, and I think it was in the abstract, that the API in C++ has to take into consideration the lifetime of the returned value. And this is something that we just ignore in other languages. If you are in Java or in Python, you just return the proper value and you're set. And in C++, we should consider, okay, should we return by value? Should we return by reference? Maybe here, at the first example, we can return by ref, because if we return by value, maybe we just return a copy, and then we copy again. Now, maybe we have copy elision if we are in C++ 17. Maybe we do not. But again, the question is, well, what should be the return value? Okay. And also we have to consider, okay, we want a variadic template. So things to consider: efficiency, avoid redundant copies, allow move if possible. On the other end, avoid dangling references. We do not want to return a reference that would be used after the reference is invalid. And there is another consideration, another question: should we allow changing the return value in this case? So if I go back, it might be that we take back the maximum and we say, okay, you know what? If it is a variable, maybe I can return the actual variable in order to allow calling max and immediately assigning a value to the maximum that was returned. Now I would start without supporting changing the return value. Okay, so I would start with returning a constant or returning by value, but this is an open question. Maybe we would go through that, maybe we would not. It depends on the time. Okay, but it is possible. It is possible, for example, in this case, since all strings should be alive when we call my max, we should be able to return an lvalue reference, non-const, and allow assigning a value to the returned lvalue. So let's take a look at a quick trial. Okay, I will just open a quick Godbolt compiler explorer, and let's discuss something that, for some reason, something doesn't look right for me. I don't know. Does it look right for you? I mean, do we have here something that actually works, or I don't know, what would you see here when I run the same code on Clang and GCC? I'm sending in the main 3 strings. Let's take a look. It's hi and welcome and bye. Okay, hi, welcome and bye. And I'm sending hi, welcome and bye, and I'm printing the maximum that is returned by my max. And Clang and GCC differ. They do not agree on the maximum. I think that the GCC, to me, it seems that the W is greater than H, but I don't know. So what is the problem here? Let's take a look. It's quite easy. Well, let's take a look at the my max. We have 2 my max. The question is which one we went through. Well, one is for variadic pack, right? So we went first to this one. And the other one is the fallback where, oh, I have only 2 arguments. Oh, if you have 2, then you should go through this one. And we also see in the printout that we go first to line 11. The 11 here is printed from here, okay? And we print, by the way, line with, and we print T here, and we see with hi, welcome, bye. How does it work? Let's think about that. We print here T. I'm trying. Oh, the printing here T is the single one, and then we use here the fold expression for printing all the rest. This is why, by the way, why I added the space here, because I didn't add a space in the printout. It's a bit more complicated. So I said, okay, this is a fold expression for printing all the rest after the first T. So we have here on line 11 with I, welcome, bye. And the same is with GCC. And then we say, okay, just call my max. And now, by reduction, we go for a smaller amount of arguments, which eventually would go for the first one. Yeah, immediately for the first one, because we are with 3, and then we would be with 2, and we would go here, and it would print 5, and then T1 and T2. In both cases, it is welcome and bye. And but then here it is welcome and bye. Again, here it is also welcome and bye. But then we can see that here we come back with hi and welcome, while here we come back with hi and bye for some reason. So let's try to understand why. So we have the first one, which is the first one, which is hi, right? And when we call my max and send hi and send the my max of these, then who are these? Who are these? There are 2 arguments which are char star. So we have here 2 char stars. And when we send char stars eventually to this function, then we actually compare them by address. So, okay, this would not work. I mean, it would not work if these are char star. Is it the responsibility of the user? I mean, is it the fault of the caller, or maybe we should design better our function? This is a question. I mean, we could have designed better the function, saying, okay, I do expect, I don't know, something that, but you know, char star is a legitimate argument, maybe or not. So eventually, this would work if I would just add here an S. If I have the proper using, let's have the proper using name space stud string literals, just to make it a string. And I think that now we have welcome with both, because now this one is a string, and eventually when we send a string and a char star, then the other one, I mean the char star, casts itself. We have a casting for either this one or the other to string, because the only way is string doesn't have a casting to char star, so the only way to calculate this one is to cast the char star to a string. But we just saw that, you know, it's a very simple example, but oh, you should take care of the arguments, maybe on the caller side. Any question or comment on this one?
So just a comment. So the greater than, there is an overloaded operator that has a string, either a string and a car, or there is a converter constructor that takes a car pointer and makes it a string, and then there's a string compared to another string, right?
Yeah, so the different scenarios that we had here were a string and a string, like for these two. If I have these two, it is a string and a string, which is okay. The other scenario might be a string and a char star, which is also okay. But if two char stars, like these two, come to this line, and they would come, then we actually check the addresses of both. And it appears that they were, you know, located on the stack on it is not on the stack, it is on that data segment. They were located on the data segment differently. I mean, Clang located them, so high was on a higher address, and GCC for other reason located welcome on a higher address on the data segment. And eventually, no, we do not want to calculate or to compare here addresses, but let's put this one aside, because well, this is not the issue that I want to discuss. Okay, I mean, I have other things to discuss, but we just saw that, you know, you have to check what are you comparing. Okay, are you still with me? Just let me know.
Yep.
Great. So I'm getting back to the slides. This was just taking a look at, why do we get a different result in Clang and GCC? Well, because the location of the char stars on the data segment is different. Nothing else than that. Okay, so let's try things together. Let's have some live coding on, we want to implement Max, okay, on Compiler Explorer, and I prepared something to begin with. And we want to check which one would work and why. So I took these two from a question in Stack Overflow. Somebody asked, okay, I implemented these two in order to have, you know, two different return values, starting with, well, I want to support both R values and maybe L values and have different implementation. And then I want to discuss, is it okay? Do we want to do something else here? What do we want to change? So let's take a look. We have the first one, and the first one takes a T double ref, which is in this case. What is this double ref in this case? I would tell
This is
you,
a forward. It's a forward
yeah,
reference or universal
it
reference.
is a forwarding reference. It is not an rvalue because t is the template argument. So it means that it can be both lvalue and rvalue. But if you actually send me something that would be a const lvalue, I would go here. So we got something that might be an rvalue, might be, and then we say, okay, if a is less than b, then return b, otherwise return a, and we try to return it as a t double ref, which is in this case, again, something which is not so clear. What is this one? Probably again, reference collapsing, then it would be either an lvalue or an rvalue. And now I want to check with you three different calls, and I'll ask you before I put them out, before I get them back to code, what we would get. This is the first example. In the first example, we call with two strings, a low as a string and high as a string. Both strings are temporaries, two temporaries. What do you think would happen if I check this out and run it? First example. Any idea?
So first of all, the one on line 10 would accept an rvalue simply because it has a const reference, and const reference would accept that. So
that's correct. I think that yes, that's correct. Line 10 accepts rvalue as well. On the other end, maybe if we have rvalue, then we would prefer this one, or maybe if we are not const. So there's a question of overload resolution here. So I think that this line 16, would call line 5. Why? Because these are two strings which are not const. They can be, if I would comment out this function, they can go to the other one, but since we have the first one, they would prefer the first one. And then the question, okay, if they prefer the first one, would it work? What would be the result? Can I take the result if it is sent back as a TWRF, as a forwarding reference? So the question is, what would happen here? Any guess? Don't leave only Kobe on the guess panel.
I have a guess, but I'll let others do kind of chime in. And it's okay to get it wrong, by the way. It's
yeah, you can just say
not
something.
easy.
Let's think what are the options. Well, the options are that it would return high, or and would print high, or it would return a low, or it would crash maybe, or it would not compile, compilation error. Any of the above, one of the above, all of the above.
So the question is the string still alive when we return? Like the whole expression. Well, where is the lifetime of string ends? Like in which part of the expression?
Yeah,
right?
and I would add to that eventually we're not taking here an auto ref, which then again would be another question. We're just getting by value. I mean, auto here is the value type of what we return. So it seems quite promising. So let's take that out of comment. Kobe, do you want to place your bet?
Well, I'm saying it's invalid just because I think the string would die and before we can make a copy. But I might, of course, I might be wrong.
So when you say it is invalid, you mean it should crash or it may crash. So I added here,
or undefined, undefined
okay,
behavior.
yeah, I added here because if something is bad and I try to use a dangling reference, a reference that is dead already, it might be that I would not crash. So I added on both sides, both for Clang and GCC, the fsanitize address in order to make sure that if I try to go to retrieve something from an address that is not mine, a dangling reference, I would crash. So this should assure me that you would not think that you are okay if you are not. It doesn't. It is not a bulletproof, but for these cases it should work. My recommendation, by the way, is that as whenever you can in debug, use f-sanitize as long as it doesn't create your code too slow. Try this because it may catch things that were not catched otherwise. Okay, let's check that, and we would see that it does not compile. We have a compilation error, and the reason that we have compilation error is that we try to return something as an R value. Well, when it has a name, and once it has a name, we cannot say that it is an R value. I mean, we got an R value. The compiler sees that this one is an R value. So the T is considered to be, the T with the double ref is considered to be an R value. So when we try to return it, we try to return it as an R value. But once it has a name, well, we have something here of a problem. Now, somebody here can say, but I'm waiting for the but.
Like originally it was our value, right? That's what maybe someone would say, but
there is a rule that you do not have to use to-move on a return value. I mean, a return value, a local return value is treated as an R value automatically. Well, not always, not always. If I got something as an argument, if I got it by value, then and it depends on the C++ version. Things evolved during the years. So eventually, the rule that says that the return value is considered as an R value is not applicable for an R value argument. And this is what the compiler says. It says that, it says here, well, we can see here, R value reference cannot be bound to an L value. And the L value is what we try to. And I think that I can show you that if I would just return A, let's say just return A, then maybe, no, let's see the problem. Oh, again, R value, okay, again, the same problem. But let's assume that I got A by value, okay, and then maybe, no, the same. So I think that, again, it is for an argument. So in order to show you that I can return something as an R value, it has to be, there is an issue here. I have, maybe if I stood move it, we would see that we have something that works. Well, we do not want just to return A, but what I'm trying to show you is that the rule that says that when you return something that looks like a local, it would move automatically, it would be an R value, works on actual local variables. And this one is not a local variable. So again, coming back to this one, I don't want to std move neither of them. So what should I have here or here? I mean, I want that to be fine. I want that to compile. What is the
so can we stood forward them? If I stood forward them, they would be.
I think that this is what I want to do. I think that I want to say, okay, if you want to return B, then please forward B, and if you want to return A, then please forward A. So, okay, now we have something that works. So let's understand what we have here. We said, oh, you are getting something, and as an R value, I want to return it as if it is an R value, I want to return it as you got it. Okay, the same thing as you got it. And then I say, but I need to forward it back in order to make it an R value back. And I'm using forwarded and not std move and not std move because it might be that this is an L value. So if this is an L value, in case this is an L value and I got here, then I don't want to make it an R value, and then I would return it as an L value because this is again a forwarding reference. And now we have this one working. Okay, let's go to the next one. The next one, in the next one, I'm sending S1 and S2. And S1 and S2 are both actual strings. Okay, let's try that. So what would happen here? Any guess? I have two strings. I'm calling my ax, but I'm taking back the result by ref. I'm saying, can you please give me the reference? to this one. Now, I have to say that in some cases, when you say const autoref, like const autoref s equals hi, okay? A question. I have this one, okay? And I want to print it on the next line. I want to print it. I want to print S, okay? Do I have another S here? No, I think this is the only S, okay? And my question is it okay that I'm having a reference to a query? And how come that it, works? And I do have the minus address sanitized here. Any idea why we see that this one is working?
Yeah,
Oh,
this
it
is
compiles.
this is guaranteed by the language.
Which is?
The lifetime, a const reference to an R value, the lifetime is maintained in the scope. So this is since day one, I think.
That's correct. So we have here a lifetime extension of a temporary. A temporary that is bounded to a const ref has its lifetime extended till the ref is dead. But, then come the but it works only on the direct assignment. I mean, if you need to extend the lifetime of somebody who is not the direct assignment, then you are in issues. And the question is here, well, it might be that S1 would return back, and I'm getting its reference, and I cannot extend the lifetime of something that was not created here. It is not a temporary that was created on the assignment or on the expression itself. And then the question is, well, there would not be any lifetime extension here because we didn't create any temporary on this line. So would it work? And the answer is, well, yes, I'm a bit confusing you because there isn't any temporary in this example. This example, well, we do not have any temporary here. We just have S1 and S2. Both would be alive. Well, both would be alive when I'm back from the function. So this function returns either S1 or S2. In this example, it is S2 because hi is bigger than hello. And in fact, S2 is being returned. And yes, we can take its reference. By the way, it is S2. Can we check that it is S2? Yes, I think that we can. How can we check that this is S2? Well, we can print the address of max2, right? Max2 is what we got here. And we can, near that, print the address of S2. I hope to see the same address. Let's see. Yeah, it seems the same address. Yeah, they are the same. I mean, you cannot expect them to be the same between the two compilers. If it would be, I would be very surprised. But yeah, on the same program, yeah, they are the same. I mean, I got back what I have here. And you can understand that if what I have here would have been dead, then I would have a dangling reference. But this one is not a dangling reference. Okay, so let's go for the last one. In the last one, I'm sending both um, a string that is alive and a temporary and a string that is alive. And the first question is, where would I go? Should I go to the first max or to the second max? What do you say? Add a printout just to make sure, right? We can add. Do we have a std out somewhere? You can think about that while we type. Okay, so here we would call it first max. Okay, and here we would call it second max.
So thinking out loud, so S1 is an L value, the high is an R value. Can T be mixed? I don't think so.
That's a good question. Can we have T be mixed? Well, that's a problem because either T is being considered as an R value or an L value. It's the same T. So
Right.
maybe we can go here. Maybe this one can work because in this one we're accepting both lvalue and rvalue, because
Yeah,
as I think
right,
Kobe, it is you that said before that this one can take an rvalue as well.
right.
So maybe this
Yes,
is a valid fallback. Okay, so
right, exactly.
let's check that. Okay, we are calling the third one. It compiles, it goes to the second max in both compilers. It should go to the second max. And then we just crash. And the reason that we crash is that I'm using the sanitizer. I think that if I would remove the sanitizer, I mean, the sanitizer is just irritating me. Let's run without a sanitizer. And we would see that, yeah, we have a max. The max is high. Oh, we are happy. Maybe we should better run without sanitizers. I mean, why should we find our bugs? Maybe let, the customers find the bugs. So here again, if we look for the max is high, and that's correct. But let's think what happens here. What happens here is that high is a temporary, and we're trying to take it, and we do not have here a lifetime extension, because the extension is only on the direct object that is being created, and there is no object being created here. I mean, we create it inside the function, inside the call to the function, and it would not catch it and extend its lifetime, which means that at the end we get a reference to a dead object, which is being dead at the end of this statement. And when we try to use it, it is dead already. And by chance, yeah, it is dead, but you can still approach it. It is on the data segment. I mean, something is there already. But if no, it is not on the data segment. It is not. It is an object. It is a string. The string was dead, and somehow you could still print it. But if you go with the sanitizer, so here you go with the sanitizer, and yeah, it even says that I think that if we read it here, that at some point maybe it shows the issue. You can follow the sanitizer and see what is the problem. So we know that the problem is with this temporary. And now comes the question: can we, in a way, say that we prefer to return a reference if we can, but a value if we cannot? So if we would say, you know what, I'm just returning a value. I'm returning a value. Then both would be fine. No crash. You are okay. Why? Because let's see what happens here. I'm returning a value. The value is a temporary that is being created here. The temporary is now being created on the return from the function, and we can extend its lifetime, which is okay. Yeah, the lifetime of the returned value is being extended. And we do not need this one to be extended because we just copy it. So this is a copy. But we do not want to copy if there isn't any need, because now we are copying also here. And here there isn't any need to copy, right? So in a way, I think that we look for something that would say, copy if you need, but return a reference if you can. Can you please assist me, Bob, without, not the syntax, but the design, the idea? How can we, differentiate between the two? What are the two functions that we are looking for? And
So
by
just
the
to
way, yeah, Kobe,
go ahead.
go ahead, please.
I'm saying so just to unfold kind of to understand the question is that you want to have an kind of an overload on the return type, right?
Yeah,
Like
it would not be an overload on the return type because I need an
in
extra,
quotes, right? There is
yeah,
no such thing. Yeah.
something in addition in order to perform the overload. But at the end, I want that if you came by with something that allows me to return by reference, then I would return by reference. Otherwise, by the way, I actually do not want to return an rvalue. I just want to return by value. I mean, I want two options, and the two options are: if I realize that I need to return a temporary, I would say, okay, I don't want to return the temporal as a reference, not as an L-value reference, not as an R-value reference. Because, by the way, returning it as an R-value reference would be the same issue. Because you are returning an R-value reference to an R-value that, in this case, is dead. No, it would not help you. So eventually, I want to differentiate between two functions. One that returns by value. I can change this to by value, but again, it would not help me because I'm reaching this function. So in a way, I want to reach this one. I want to say, okay, oh, in the last case, maybe you can reach this one that returns by value. How can I say, I want you to reach this one? And then, by the way, maybe I don't have to forward because, or maybe I do. Yeah, I do want to forward. Why do I want to forward? Because otherwise, I'm actually copying. I want to say, yeah, when you are copying, go through the move constructor if you can, which is fine, which is good. Yeah, preserve the forward. You need the forward. But what I want to achieve is that, in some cases you would be there in this one, and in other cases you would be on that one. And the cases that I want you to be here is the cases that the T is an actual L value on both sides, and here, one of them or both are R value.
So just looking by the abstract and having constraints on, basically, if we had a language that says, go to this function if T is an R value.
Yeah, I think that
if we had such syntax.
Yeah, you're using the prior knowledge of, I know what was the abstract or the title, but I think that you are skipping one step. I mean, in order to require something or to sfina or to restrain my function, I first need to allow these two T's to be different. Let's recall, the reason that we got to the second one was that the first one didn't match. Why? Because the first one requires two T's which are the same. I mean, they should at the end be the same reference type. And we want to support this one, but in this case, one of them are rvalue. Okay, so the first step should be to allow.
You want to split. You want to have more another template parameter. That's what you want to do.
Yeah, I need two T's. I mean, in order to allow to say, you can be two, you could be this one or the other, and then the question is, so what would be the return value? I mean, would it be T1 or would it be T2 or it cannot be T because I don't have any T by now. So what should I put here? The answer is quite simple. What about auto?
Yeah.
Auto should work. Auto should be okay. And auto is by value. Now, if I would want to do something, complicated, like, in some cases, I want to get you as an R value, and in other cases as an L value, then I might want to do a decltype auto. But this is not what I want. I mean, decltype auto would say here, well, take a look. You should see what you are returning. And decltype auto might be R value or L value, depending on what I return. And because if I just say auto like that, then it means an L value. Someone can think about, what about double ref? I think the double ref would also say the same, but anyhow, I don't want an R value. I want an actual by value, because in this case, you need to copy because you have something that is going to be dead at the end of the statement. And I want, if somebody takes it into a reference, and someone that calls the function doesn't really know. He says, I saw that you're using a const ref. I want to use the same. So I want this one to work without crashing. And in order to allow that, I would say, okay, I'm returning by value. So we have the two T's. And by the way, we need another forward. So if it is B, which kind of T should I use here? T2, because B was T2 and A would be T1. Okay. Let's see what we have now. We're back. And what about the last one? It seems that the last one, we are with a sanitizer, right? We are with a sanitizer, and we do not crash. How come we do not crash? Well, we went to the last one, so it seems fine. But then there is a question of, can we actually get any kind of two T's? I mean, in some cases it would work, but in other cases it would not. And you know, might be that I want to say something about the two T's that it seems like that, like you can, you know, accommodate any T's without any connection between the two. This is one question. And the other question is, well, if you see that you got a ref, like something which is an L value, do you require both T's to be the same here? I mean, suppose that I have two different T's here. Yeah, I think that I require them to be both the same because I want to return something which is the same, right? But it means that, can we think about something that would not be able to go here? Something that would not be able to go here. I think maybe. Let's try it. Suppose that, I'm not sure, but we can try. Suppose that one of these is a const. Let's see. No, nothing changed. Well, I think maybe because it removes top level const. No, I think S2 T is considered as the const is being in the function, and T is the string, right? And the other T is a string, and here T is also a. It is interesting to think about what is deduced for T. Which function do we go here? This is what we need to check. Okay, back. It says max 2, right? Let's put all the others in a comment. Okay, this is in a comment. This in a comment. Okay, we call here. Oh, we call the first max. That's not good. Do you see here? We call here the first max for some reason. And we actually do not get the same address as we had before. So for some reason, even before I do the const here, maybe when I do add the const here, we then go to the second one. No, still the first one. Okay, so in a way, we have a first one which is quite greedy. It is quite greedy. It takes what previously went to the second one. I mean, here we have two L values. This is an L value. This is also an L value, right? Let's try another one. Let's say, suppose that both of them are const. I'm trying to get to the second one in a way. Maybe. Oh, yeah. Now we got to the second one. But it is not that always I would have both const. So somebody can say, okay, so maybe you can just, you know, copy this one and have another one saying, oh, if I got both as non-const, I would still return const because I put aside the question of should I enable changing the return value. Let's call this the third one. And then even if you go without const, right, like that, then you would go probably, back to the third one. Yeah, to the third one. But I would say that this is nice, but it is not what we would aim for. What is the problem with this approach? Yeah, we actually now we are able to differentiate and say, oh, if you're in an L value, I can catch you in the L value version, which returns an L value. What's the issue?
So first of all, mixing L value and R value would probably fall back to the first one.
I think that if we mix L value and R value, we are okay. It would fall back to the first one, which is
first
fine.
One. Yeah.
Which is okay because if one of the guys is an R value, we want to go to the by value, return by value,
right.
Which is okay.
Yeah.
The problem is that if one of them is const and the other is not, then we fall back back to the first one.
Yeah.
And the reason is quite clear because you do not match this one and you do not match this one. So we have another one. So you can say, oh, so we just have to prepare additional only two in addition. One that gets a const and an unconst, and another one that gets an unconst and a const. But then I would tell you, well, you know what? We just started. At the end, probably not today because we would run over time, but you want it as a variadic pack. You cannot go with, oh, I have to create all versions. No, you cannot create all versions. So in a way, I want to, tie them together. And the best way to tie them together is to say, you know what? I want to tie all to this syntax. Because this syntax, as you saw, there is a reason. There is a reason that Scott Myers initially called this one universal reference. We now call it forwarding reference, but it is very universal. It can get anything, which makes it quite greedy. But if there is a perfect match, another perfect match, we go here. But it is quite hard to create a perfect match, especially if there is a difference between a const and an unconst. And I want to catch all different combinations of lvalue, const and unconst on variadic pack. So no, I think that we cannot go this way. We need to say, you know what? You have only this one. But wait, if you have only this one and you return by value, this is not what we want. So I think that what we want is to say, no, you don't have these because then you have to take care of all combinations. You don't have it. You have this one and you have it twice. Let's say you have it twice. Well, this would be a compilation error, right? They are the same. Okay, the first one returns by value. Because, okay, I'm here in order to accommodate the R value, even though these are not R values, these are forwarding reference. The second one would be, oh, I'm here to accommodate the L value case. They are the same. They are the same. We need to differentiate between them in a way. How can we differentiate? How can we say, no, 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 they are not the same? Here, I mean that, oh, this is for the case that either T1 or T2, one of them, is an R value. And here, oh, this is for the all other cases. How can we say that? With a constraint. So eventually we want two variations, two options. The first one that would say, I want to deal the case for the case where there is one which is an R value. By the way, also in the variadic pack, if a single one in the variadic pack, we would not do the variadic pack, but it is possible, is an R value, then we would say, okay, this is mine. And this is for the case where none are or is, how should I say it? None are, I think, an R value. Okay, which means all are, i.e., all are L value, const or non-const. So in a way, I'm using here the forwarding reference in order to catch the const and non-const, but only for the L value. Okay, how can I tell that? What should I say? Please help me. I want something like requires right? Something with C++ 20 requires close, requires something.
So you want either T1 or T2 and R value, right?
Yeah, so some kind of a type trait, right?
Type trait, yeah, using a type trait.
Should is our value, maybe? There is something like is our value. I'm using your help here because, it's a live coding. I don't remember. It's not that, I remember that by heart. There is something like that. Maybe we need to include.
There is an is our value reference.
So I want to add here type
traits.
Type traits, like that.
Traits, yeah.
And I want to ask, is our value
is our value underscore reference underscore v reference underscore v.
Like that? Okay.
Yeah.
Yeah, once it says too few template arguments, it means, oh yeah, I found that, but now you need to bring me some template arguments. And where's the one? T1.
So T1.
Okay,
and then
so
we can have all, right?
Or because eventually in the requires clause, I should put some Boolean expression, and here I want to ask about the T2. Oh, now we have two functions that can be differentiated. I mean, there is some required clause. So if you meet the requires, it means that this is your choice. Otherwise, you go to the other one. This is how it works. Now, then the question is, which one of the two did we call? Well, in the first case, we still call the first one. I think that we are not too happy. I mean, here, I have the const and non-const, right? And when I call the function here, both S1 and S2 should be considered as an L value, right? So let's ask ourselves, why is our value reference V of T1, why it is being considered as an R value? We would find out. There is a reason. Let's start thinking about what is the issue here. The deduced type of T1 is, I think it is, and you should help me here, because once we would solve the requires clause with a proper type trait, we would achieve what we want to achieve to differentiate between the two. Now we can say, okay, if this didn't work, and it should work, I mean, we can amend that once we have the proper thing, is we may ask, okay, maybe we can ask whether this one is an L value reference, and also both should be, right? This one as well. And oh, again, you do not go to this one, maybe because the requires clause is not met. Something is broken with my requires. Okay, so luckily for me, I have the fallback, and I would just pick at the fallback, and I would find something. It seems quite similar. I would share what I'm looking at. Okay, I would stop the current share, and I would share with you what are my cheat sheet. Okay, so the cheat sheet is a Stack Overflow question. Let me show you this Stack Overflow question, which is this one. Okay, so you see here the original question that brought me to this talk. There was a question in Stack Overflow starting with something very similar to what we started with, right? I want to create two max overloads, this one and the other one, and it doesn't work nicely. And I liked very much the answer. There was a very elaborated answer saying, oh, if you start with this one, this could be a direction, but then it would not work for that. So you can have this version, but then it would not work for the other one, etc., etc., a version after a version. And then it comes to the version, oh, and then it comes to, oh, you can create all variations, all combinations, a constant and unconst, both const, both non-const, but you don't want to do that, because if you are with variadic pack, you are stuck. You are not going to create all combinations for an unknown set of variables. It is impossible. So what you want is at the end to have two, this one and the other one with the requires. And this is what I'm trying to achieve here. So I think that what I would do is just try to copy that. Maybe if there is something very small that I probably miss. I mean, it looks quite the same. Oh, with another one, there is also is same V. There is also, if both are L value, but they are not the same. If both are L value, but they are not the same, it might be that the return value would be casting. A casting, I mean, suppose that the auto says, okay, I have to return this one, but for the comparison, I did a casting, so I have to think about that, but it might be that it would still be dangling if you take that to the wrong type. You think that you get a string, but it was not a string, you get a const ref, and you actually cast something. So there is also another thing, but I think that this is not the problem. So even if I take only this one, by the way, the answer that I like was written by myself. I mean, I was the one that wrote this answer, so I should have, remember what I did, but it was a while ago. It was on January. Okay, some time passed. So I'm trying again to say, okay, these are the two. Let's take them. Okay, I'm taking these two, and I'm going to my compiler explorer, which you do not see currently. I mean, you do not see because I'm not sharing this one, right? I'm sharing still the Stack Overflow. And let me see if it would, and it works. So I have to share with you, and then later on we can take a look and analyze the reason of, oh, what is the difference between what is in Stack Overflow, which, somebody invested some time there, and the one that I just, in a demo, in a live coding tried to do. Do you see my compiler explorer now?
Yes.
Copied from Stack Overflow. And now we do see that you call the max. Oh, we do not see. I thought that we see. Let's add here. We still don't see. This is the first one. This is the second one. Okay. And do we see that you call the second one? The second one. This is the second one. And we see that you call the second one, which we want. But why do we want the second one? Because the second one is the one that is appropriate for 2L values. And we're in the 2L values. And if I get you to this one here, we would see that here you call the first one. Oh, how nice. You call the first one. It's good because you would not get a dangling reference because I return by value. And the by value can be extended. The lifetime of the by value return value can be extended. And this one would also work. This one, in this one, you just, send 2R values. So again, you would call the first one. And the nice thing is that you do call the second one. You can see here that you do call the second one. So I want to go back above and try to realize what is the difference. Maybe the difference is, again, this is same v. I'm trying to put the is same v in a comment. I mean, if you do not have this one, would it change? I only have the is lvalue reference t. And you still call the second one. So you should help me now. What is the difference between the requires clause here and what we see here? I mean, it is probably very small, a small detail. Is lvalue reference v of t1 and is lvalue reference of t2? Do you see any difference between what I ask here and above?
So,
and this one works. I mean, you see that you go to the second one when both are L values, regardless of whether they are const or not, which was our goal. So again, I don't see the difference. There is the difference, otherwise they would behave the same.
the return value is
oh,
different.
the return value. The return value.
Yeah, you have a const.
The return value for some reason does not correspond. So let's put them in a comment, and let's go back to the original code, and let's see why the return value has such an influence. Okay, so back, and now again you go to the first one, and now I say, okay, I just want to return auto, or when we go to the second one. So let's try to understand why when I add a const on the return value, what is the reason? Maybe this would be homework for you and for me. I mean, there is a difference here when I added const. I think maybe it affects the overload resolution. Might be. No, should it affect the overload resolution? Might be. Anyhow, these two. Now, okay, now I actually return something that you can change, which was not in the requirements. Maybe it is good, maybe it is not. But at the end, we did achieve the difference between, oh, I can return by ref when I need, and I would return by value as a copy when I should. And again, the question of, oh, there is an issue with the const, we need to understand that, but I put that aside as a homework. Any question of what we achieved here? And the next version would have been the variadic pack. And if you want to go for the variadic pack, then I would go back to the slides and would tell you that after the live coding session, live coding is always fun. I mean, it is tiring. It is intimidating. Something can go wrong, but then you go back to your cheat sheet. This is the main resource. I mean, the Stack Overflow question that I started from. But there are other additional related resources, including those who implement the variadic pack version. Some of them are mine. And there is a very old Dr. Dobbs article on the same issue from 2001. I mean, there wasn't rvalue semantics, and still this discussion was relevant because temporaries were there. So it is quite old issue, which people still, in some cases, do wrong. I mean, it is a bit wrong if you return a reference which can be dangling. I mean, I return a reference to a rvalue which is dead when you get it back. If you get it back to a copy, like here, it's okay. But once you can add a ref, and I allow that, you have a dangling reference and something is wrong in the API. And what we wanted to achieve is an API that does not allow you to get the dangling reference. You would either get a copy for which lifetime extension is okay, or you would get a reference when you actually have a reference. So this was our journey, and the links here would take you to the rest of the journey, to variadic packs and other considerations. I'm open now for other questions if you have any, including if you want to play with that a bit. I mean, can you check that? Can you change this to that, etc.?
So a couple of things just out of the bat. So one is people asking if we can get the slides, at least the links, and this is one thing. The second thing that I just wanted to mention is that I think there is maybe kind of experimental feature in Clang, I think, about lifetime warnings. I think it's -w lifetime or something like that, that is relatively new. I can Google for that, by the way. It's from the top of my head.
I can try it here. Lifetime. Let's see if it gets that or gives me something. No, it says that.
I think it's W. I think it's W lifetime.
Like a warning on lifetime.
It's capital W, I think, lifetime. But I'm kind of
no, but minus W is okay because it's like I want to open a warning, but it doesn't take lifetime. Anyway, yeah, we can check that. But the fsanitize assist me here. I mean, with fsanitize, I would catch the issue, even though sanitize adds things to the executable in some cases, or it adds time. I mean, it affects the timing of the program. I cannot use it always. In some cases, no, it affects the program and it makes it too slow. So yeah, if there is something that can catch me in compilation, that would be even better.
Yeah, I can remember exactly, just from the top of my head. I thought there is something experimental. Maybe there is a Clang branch that needs to happen. But yeah, I can't remember.
And I think that right after the talk, the next thing that I would go and check is why the const makes this change the behavior. If I remove the const, I'm here I again call the first max on both. What changed? It was the second max, right? I think that I saw the second max and now I see the first max again. What did I change again?
So we need to go. The cout says both of them says
Oh, the
first.
cout says first on both. There, yeah, good catch. Okay, nice catch. Some of the Control Z that I did. But again, if I go to const here, then I think that we saw that that you. Oh no, you go. The const didn't change. So I really don't know. I mean, I have to look for that. At a certain point, it seemed that when we did the requires, it didn't work, but it does work. I mean, even if I return a const, we thought that the const is the difference, and here I see, well, we have two. One requires is lvalue, and we go to the second max as we should, right here. So I don't know. Again, it's a live coding, and with live coding, something is of a difference that I miss somewhere that caused the one of the runs before to call the first one. But again, the idea is that we want to differentiate between two functions that look exactly the same. I mean, both take coding reference. And then I want to say this one is for the case where all are lvalue reference. By the way, when you go for variadic pack, do you know how I do that for variadic pack? You know, it's quite easy. It would just go with a fold expression. I mean, it wouldn't work now because it's not a variadic pack. But when you go for variadic pack and you just want to say, and I have the rest, the same condition for all the rest, C++17 just allows you to do it quite nicely, quite easily. So we would not do the variadic pack version, but it is out there in the links at the end of the presentation. And there are other goodies also out there. I mean, you can think of many other things, like, for example, can I allow different types? Here, I think I don't say anything about that, but if there are different types, I have to think about to which function it should go. It depends whether there are different types which can convert one to the other. If not, both should fail. But this is the base. I mean, you should differentiate on the question of, can I return an lvalue? Oh, you can, because all of them are lvalue. Any question or comment? Applauses are also welcomed.
Thank you so much. It was very, very good, very fun to watch it. So I'll get the slides from you after the session. Thanks you so much for coming over. I know it's late at night for you. Thanks for that. Anyone wants to ask anything before we close the session? Okay. Thanks, Amir.
Thank you, everybody. See you
Take
around
care.
in other C++ occasions, or in San Diego or in Tel Aviv.
Thank
See you.
Thank you. Take care. Take care. Bye-bye.
Bye.
Thank you.